we were looking at how do we find expected values using the joint PMF, where we talked about how we can use the joint PMF of x and y to find expected value of just x, expected value of a function of x, expected value just y, expected value just a function of y, and find expected value of function of both x and y. So we were looking at this example where we first looked at how do we find expected value of x, expected value of x, where we now want to look at how do we find expected value of y. Now, approach one is that we can directly use the joint PMF of x and y without having to find the marginal PMF of y. So we can find this using directly the joint PMF of x and y. For this, let's recall that to find expected value, gxy, we can find it as summing up gxy probability x is x and y is y over all possible ordered pairs xy. When we're finding expected value y, so this gxy is just going to be simply y. So expected value y is just that you sum up over all possible ordered pairs y times probability x is x and y is y. So how do we go about doing that? So over here, this is our joint PMF. So here we know the first ordered pair that we're looking at, we have to sum up y times probability x is x, y and y is y over all possible ordered pairs x and y. The first ordered pair here is x is 0, y is 1. So over here, it would be like this ordered pair 0, 1. So here, the y value for this ordered pair is 1. And what is the probability for joint probability of this ordered pair? That's 1 by 4. So this is 1 times 1 by 4. The next ordered pair here is 0, 2. And the probability for this ordered pair is 0. Right, so the ordered pair is 0, 2. The y value is 2 and the probability is 0. The next ordered pair is 1, 1 and the probability is 1 by 2. So here we know the ordered pair is 1, 1, the y value is 1, the probability is 1 by 2. Plus the next ordered pair is 1, 2 and the probability is 1 by 4. Right, so here the y value is 2 and the probability is 1 by 4. So we just find y times probability x is x and y is y over all possible ordered pairs. And here all possible ordered pairs were x is 0, y is 1, x is 0, y is 2, x is 1, y is 1, x is 1, y is 2. Another approach to find, so here we looked at how we can find the expected value y directly using the joint PMF without having to find the marginal PMF y. Another way to go about finding expected value y is to first find the marginal PMF of y from joint PMF of x and y and use that. Right? You can first find the marginal PMF of y, i.e. Marginal PMF of y would list down the values y can take along with the associated probabilities, and we can use that to find expected value y. But we can also directly use the joint PMF without having to find the marginal PMF of y as shown in approach 1. Similarly, we can find expected value y square using either approach. Approach 1 would be to directly use the joint PMF of x and y without having to find the marginal PMF of y. Like we know, expected value gxy is given as summing up gxy times probability x is x and y is y over all possible ordered pairs x and y. Now, when we're finding expected value y square, gxy is just simply going to be y square. When finding expected value y, gxy is just simply y. When finding expected value y square, gxy is simply y square. So to find expected value y square, we just sum up y square, probability x is x and y is y over all possible ordered pairs xy. Initially, to find expected value y, we summed up summation y, px is equal to x, y is equal to y over all possible ordered pairs x and y. Here to find expected value y square, you do the same thing, but instead of y, we're going to do it with y square now. So the first ordered pair we know is 0, 1, x is 0, y is 1, and the probability is 1 by 4. So here this ordered pair is 0, 1, the y value is 1, so we have 1 square times the probability 1 by 4. The next ordered pair is x is 0, y is 2, and the probability is 0. So here the ordered pair is x is 0, y is 2, so y square, the y value is 2, so it's 2 square times the probability is 0. The next ordered pair is x is 1, y is 1, and the probability is 1 by 2. So here the y value is 1, so it's 1 square into the probability of this, which is 1 by 2. So the next ordered pair is x is 1, y is 2, and the probability is 1 by 4. So the y value is 2, so it's 2 square into 1 by 4. And approach 2 would have been, okay, we could have first found the marginal PMF of y and use that to find expected value y square. But like we know from approach 1, you don't need the marginal PMF of y. You don't need to first find the marginal PMF of y from the joint PMF of x and y. We can just directly find it as well, expected value y square. So key takeaway is To find expected value of x, expected value of any function of x, such as expected value of x squared. To find expected value y, expected value of any function of y, such as expected value y squared, we can directly use the joint PMF of x and y without having to first find the marginal PMFs, right? We can directly use the joint PMF. You don't need to use the joint PMF first to find the marginal PMF. Lastly, we looked at how we can use, lastly, want to look at how we can use the joint PMF of x and y to find expected value of a function of both x and y. So far, we've looked at how we can find expected value of x, expected value just a function of x, expected value y, expected value just a function of y. We now want to look at how we can find expected value also of a function of both x and y, such as expected value xy. Here again, recall to find expected value gxy, we just sum up overall possible ordered pairs gxy, probability x is x and y is y. And in this case, gxy is just xy, right? So we're summing up overall possible ordered pairs xy into probability x is x, y is y. So if we go back to what all possible ordered pairs are, so the first ordered pair is x is 0, y is 1, and the probability for this is 1 by 4. So the x value 0 times the y value 1 times the probability 1 by 4. The next ordered pair is that x takes a value 0, y takes a value 2, and the probability is also 0. So here the x value 0, the y value is 2 times the probability 0. The next ordered pair is x takes a value 1, y takes a value 1, x takes a value 1, y takes a value 1, and the probability is 1 by 2. So it's just x value 1 times y value 1 into probability 1 by 2. The last ordered pair here is x takes a value 1, y takes a value 2, and the probability is 1 by 4. So it's x value 1 times y value 2 times the probability 1 by 4. Similarly, we can find expected value of any other function of x and y using the joint PMF. So we can use, if we go back, so the idea is that, so using a joint PMF of x and y, we can find expected value just x of a function of just x, just y, function of just y, or a function of both x and y. We did it for expected value of x times y, but we can find expected value for any other function of both x and y as well.